When you work with chains, you don't want that they split across racks. You want them in one rack and one line. And here's how to do that, so that you have a nice and clean setup.
I have prepared a short demo show for you with 58 shells in total. When you look at the timeline of this show, you see 5 singles, followed by 8 6-shell chains, followed by 5 more singles. The 3-inch racks in the generic effects collection have 10 tubes per rack, so the racks, add racks for show function, which is used to add the minimum number of racks for the show, will add 6 racks to the show. We'll start the example by assigning tubes in those 6 racks with the default addressing configuration. The addressing greater than address show menu item brings up the dialog you see here, by default, which sorts the addresses in a position by event time, and doesn't have any constraints other than preventing module wires from stretching across positions. The default addressing configuration assigns addresses and tubes in chronological order, sorted by event time. Without anything to suggest otherwise, the assignment proceeds with the first chronological shell in the first tube of the first rack, then the second, third, and so on, until reaching the first chain, here pin 06, whose shells continue to fill the first rack and spill into the second. This illustrates the problem: the chains are split across racks. Show designers usually avoid splitting chains across racks if at all possible. They usually prefer filling racks entirely with chains or singles, one or the other, if that's possible. When that's not possible, such as when the chain sizes don't match up evenly with the rack sizes, they usually prefer filling up the extra tubes in the racks with singles. The easiest solution to prevent chains from splitting across racks is to add the constraint that each pin is restricted to a single rack. By definition, a chain has one match, on one pin. Thus all of the chain's shells are associated with that one pin. If that pin is restricted to a single rack, then all the shells associated with that pin, namely all the shells in the chain on that pin, will be restricted to the same rack, which prevents the splitting. Let's look at the result of the each pin is restricted to a single rack constraint. The first 5 shells chronologically continue to fill the first 5 tubes of the first rack. But at that point, the chain on pin 06 can fit in the 5 remaining tubes in that rack, so the entire chain is allocated to the second rack. The next chain with pin number 07 can't fit in the remaining tubes in either of the first 2 racks, so it spills to the third rack, and so forth. Unfortunately, with the added constraint we no longer have enough racks in the layout, so 3 chains remain unracked. The red pin numbers in the module diagram in the lower left are the indication that the shells on those pins are not fully racked. We'll need to add 3 more racks manually since the minimum number of racks is no longer sufficient. But wait, before we add the racks, let us first rearrange the assignment order so the chains are assigned first, and the singles second. Readdressing the show again with the chains first criterion added to the assignment order will change the assignment order to begin with the 6 chains, followed by the 10 singles, instead of beginning with 5 singles that are shot earlier than the chains. The result of adding the chains first criterion is a very natural rack assignment. The chains fill the racks nicely, and the singles fill the gaps left over after assigning the chains. The only remaining problem is that 2 chains remain unracked, signified by the 2 red pins in the module diagram in the lower left. The addressing sorts and constraints provide a great deal of control over the manner in which tubes are allocated to chains. Adding 2 more racks from the racks palette, and readdressing with the same configuration as before, is the final solution. Notice that the module diagram in the lower left has no red pins. The rack assignments are perfect now. You see, the addressing sorts and constraints provide a great deal of control over the manner in which tubes are allocated to chains. But preventing chains from splitting may result in a need to add more racks.